Okay, I was trying to record the first take on this thing. I had finished it, and it died on me, so I'm a little bit fired up right now. So I've got everything that I've written, but you can't hear anything that I said. And there's stuff that I erased, so I'm going to have to just start over. And so here we go. So here's the joy of technology. So some of this stuff we can do relatively quickly because it's just a matter of reading it. Oh, come on. All right, we're going to introduce the idea of polar coordinates. And polar coordinates have a direction, which is an angle, and a distance, that is a radius. There's going to be concentric circles that you're going to see in some of the graphs or on the graph paper that you have. Now, I can't erase anything right now. I'm not going to mess with that. But anyway, the thing I wanted to point out is you have the origin is the x-axis, origin is the pole, and the positive x-axis is your polar axis. So that's what we're going to be dealing with now, is just this one positive x-axis is all we have that we're going to be working from. And so again, to see what's going on with this, I think I'm going to erase this stuff and talk about it again. The direction is going to be the rotation from the positive polar axis, and again, the pole is your origin. It's like your origin in a rectangular coordinate system. The radius is the distance that you're going to move in that direction, so that's what your r and your theta are going to end up being in this particular instance. So if you want to read all the rest of that stuff, pause it, but you are moving on here, or we are moving on. Now, as you can see, I already did all the calculations and I drew stuff everywhere, and I need to start repeating whatever I had talked about before. And I need to use a different color so you can highlight and see things. And there's some of this stuff that I could probably erase and we could redo this. Okay, so that's what we're going to do. This angle measure right here has got radian measure. I personally don't care if we deal with degree measure, especially in trig, but if we are doing calculus, we have to be aware of radian measure. So, and this is for Calc 3 review people as well. Now, the thing that you need to know about polar coordinates, I think I'm going to erase all my little gyrations here that I did so I can explain what happened. All right, if I was to graph this point right here, 7/6 pi is in quadrant 3, and we're supposed to go 3 units, and if I zoom in a little bit, you can kind of see the circles, and so this is our location right here. Now, the thing you need to know about rectangular versus polar, rectangular you have one way to represent a location. For polar, you have an infinite number of ways to represent that. This is when I added 360 to that angle. That's a way to do it, and I could add another 360 to that, which means I'm doing 2 rotations, and that's what this one's going to turn out to be. So it would be a matter of me doing 1 rotation and 2 rotations and ending up there and going 3 units. Now, that's not the only way to do this. I can also graph it this way, pi sixth or 30 degrees. You're pointing in the direction, and I really should have done a different color. So you're pointing in this direction right here. That's the 30-degree direction, but you're going to walk backwards to end up at this same location right here. And again, you could add another 360 to this one, and you're talking about a 390-degree angle. That would mean that you've done this, you've gone all the way around going to here, and then you've walked backwards 3 units. All right, let's go on to the next one. Again, you can think of this. Go away. All right, you can think of this one right here as a negative 45 degrees. So that's pointing in this direction. And so you're supposed to go 2 units, and you can kind of see you're going to end up at this location. Is that the only way to do it? Heavens no. You could do a complete rotation around here to 315. That's what this one is. Or you could just rotate to 135 and then walk backwards 2 units. And that's what this one right here would be. Alright, so let's see if there's anything here. Nope. This is just talking about walking backwards when you're going in a completely 180 degree opposite direction. Alright, so we're going to move on. You're going to get the quick version of this one. I could not do this for 40 minutes again. We'll take a break after this and we'll do the next one a little bit quicker, or shorter, I mean, or not quicker. Okay, so when you're looking at this one, -2 pi force is the same thing as a -2, 45 degrees. So you're going to be pointing in this direction right here, but you're walking backwards to get you to this location. So that's why that point is located right here. When you see a -pi-halves or any kind of quadrantal, that is just a happy circumstance because you're facing in this direction, which is the same thing as a -90 degrees, and you're walking backwards 3 units to get to this particular point. Okay, let's move it up. And this angle, this 0 that you see, that's in radian measure. That's what I was trying to indicate because you don't see a degree symbol. And so you're pointing at 0 radians, which is the positive x-axis, and you're supposed to go 4 units, and that's going to be this location. Alright, and then last but not least, looks like I've already used green for this from an earlier attempt. And like I said, I finished the whole thing and it went away. But here's going to be our pi-6th, and we're supposed to go 2 units, so we go 2 units in this direction, we end up this point. And we could also do a situation where we rotate a -11 pi-6, which puts us right here at that same location, and we go 2 units and we get this. Okay, and another color, oops, not that one, let's do orange. If I was to do this particular point, then this would be one that I rotate all the way around and come back to here. That's my 13 pi-6 that you see, and I have my radius of 2. So you're going to end up with the same location that we got. There's 3 different ways to get that same location. So this is saying, again, that rectangular coordinates can be done one way, but polar coordinates can be done, how about an infinite number of ways? So off we go. So let's see, let's talk about this one. And I guess I'll just stick with orange. When we want to convert from rectangular coordinates to polar coordinates, we need to remember certain things. Now, what I've got written here actually is the other way around. This is going rectangular to polar. So I guess I'm going to talk about that first and then come back to the other. Yeah, let's see if I can do that for you. Rectangular to polar, we need to be able to do the following. We need to find the radius, which is basically the Pythagorean theorem, and then you can choose which one of these that you decide to do. It's entirely up to you. Okay, as far as polar to rectangular, we'll do that a little bit later, and I'll write it. I think we got some examples that I can show you there. Alright, so this is rectangular to polar. What I said on the original video was that I love to see something that's a quadrantal. The point 03 is located right there. It's located right there. And so when I see that, I don't need anything to tell me that I'm going to go 3 units in the 90-degree direction. So when I see a quadrantal, I'm as happy as can be. Okay, I can identify that without any hesitation, and again, you can use pi-halves if you prefer pi-halves. But if you had to work it all out, okay, you would have to figure out the radius by doing this unnecessary work right here. And then the other part of it that I had originally that I erased is that you have the tangent of some angle that's going to be equal to a 3 over 0 because we're using this thing, the y over x. And so that means then that this is undefined, and it's going to be undefined when you are talking about a 90-degree angle. Technically, it's also a 270 besides a 90 degree. Well, that's interesting. The orange shows up well on the black here, or the dark. Got to look at positives. Okay, so why in heck don't I use the 270 if that's also going to be undefined? Because this point right here, this 3, is a positive. So I would not go in the 270 degree direction if that's the case. So I would not use that even though I know that's another place where that angle is undefined. Alright, if we were to do the next one, I need to erase the stuff that I've just done. As beautiful as that is. And I need to graph the point that we're talking about here, which is 2, -2. It's this location. So I did the Pythagorean theorem and I ended up with this. And then as far as the angle is concerned, how the heck did I figure out this angle? It's entirely up to you what you use, but I still use tangent in this case. It's a tangent of some angle is equal to that -2 over 2, and it's going to work out, of course, to be a -1. And so that tells me I have a 45-degree reference angle. And I have to remember then that a positive and a negative right here is going to put me in quadrant 3. So an angle in quadrant 3 that's 45 degrees is going to be 315. That's 315 in what looks like neon orange. Okay, so that takes care of the second one. The third and the fourth one, again, I need to erase my other orange stuff so you can see a graph. And if I calculate what this part right here is going to be, it's going to work out to be a 2, because the square root of 4 is a 2. And then if I plot the point, which I forgot to do, it's going to be about right here. That's the location of -1, -square root of 3, and I'm not going to try to mark that unit off. And so what you can do instead of tangent, if you want to, is you can use sine, because you already know the radius is 2. And so the sine of what angle is going to be equal to a -square root of 3 over 2. It's a 60-degree reference angle in quadrant 3, so that's going to give you 240 degrees. And that's where that thing came from. So it looks like I didn't scribble or erase anything there. Anyway, so I'm just going to leave that on the screen, except I'm going to erase my point. And if I plot this point right here, it's going to be about this location. So again, when I calculate what the radius is a 2. If I figure out the sine of what angle is equal to 1/2, it's a 30-degree reference angle. But it's in quadrant 2. And I was so clever with the original video, I put 30 degrees in here and said, look at that, I made a mistake because it's in quadrant 2. And I did it on purpose. But anyway, so it's quadrant 2, 30 degrees, it's going to be 150 degrees because I'm going to do 180 minus 30 to get 150 degrees right there. Now, this other one that we have is one that you're supposed to try for yourself. So pause it if you didn't see the answer already before I erased it. But anyway, pause this and I'm about to write the answer. You're going to have 3 to the square root of 2, and the angle is going to be 135 degrees. That's what the answer would be. So you can try that one yourself. Alright, so here we need to talk about, well, it's just an example of doing multiple points here, I guess, is for the same point. So I'm going to erase this part of the picture, and I may reconstruct that each time. So when I'm doing part A, we have a restriction about that the angle has to be from negative 360 to 0. So if I have to have a positive, and I'm going to graph this, ignore that for now. Well, actually don't ignore that. That's going to be the same thing as going in a 135 degree direction, which is this direction right here. Alright, so one way you can get there to be between negative 360 and 0 is to go in the negative direction, and that's where the negative 225 comes from, and you're walking in the positive direction, so you're going in the same direction as the angle. If you do C next, because it's the other one that's positive, then you could do a complete rotation, and that rotation can go something like this, where you do 360 plus another 135, and that's going to give you this angle. And again, you're going in that same positive direction, so you're good. So let me erase that rotation. And now, when we do part B, alright, so let's see, where was I? I'm talking about the one that's a negative rotation, so I need to be pointing 180 degrees in the other direction. So I need to rotate all the way around to here, which I've already indicated is 315. Because if you take 180 plus 135, that'll give you 315. But I'm facing this way, but I have to walk backwards to get to this location. So that's the other point that you have. Alright, so when you want to go from polar to rectangular, and I'm tired of orange. I need some green in my life. So polar to rectangular, you need to remember those relationships which we talked about the first week of trig. Or in pre-calc, we talked about it when we first started the trig concepts. So we're going to use those relationships, and I'm going to plug in the 6 and the angle measure, and I'm going to calculate that this is 6 times the square root of 3 over 2, and I get this angle, or this value for x, I should say. And I did the same thing for the y using that relationship, and I end up with a 3. So here's my point, and it should be in quadrant 1. Looks like I can't use green. Looks like I can use red. So again, if I figure out what x is, I have negative 4, the cosine, of a negative pi fourths, and I end up with a negative square root of 2 over 2, because the cosine in quadrant 4 is a positive right there. And when I do this one, okay, it's in quadrant 4, so that one's going to be a negative, like I said. So a negative times a negative gives us a positive, and that's where we get that set of points. And it's too late for me to erase your students' try one, so just try not to look at it, I guess. But if we were to do this one, again, it's the radius times the cosine of the angle for the x, and the radius times the sine of the angle for the y, and here's your calculation for this. And again, if you were to try this one, here's your answer, and I'm not going to erase it. You're just going to have to just try it to make sure you get the right thing. I will make sure that I unerase it, or I uncover it so you can see what it's supposed to be. Alright, time to move on. I can safely say you're going to get a quicker version of this. I don't know if it's a good version, but I need to go ahead and keep going. Actually, we've already done that, so I don't need to do that one again. So now I need to show you what's happening for these. Alright, so we're supposed to convert from polar to rectangular the equations. My Calc 3s, you're going to do a lot of this, so beware. This is where my pen was starting, the rubber tip was coming off, so that's why you're getting the clicking. I don't have a rubber tip on my pen any longer. But I'm going to multiply both sides by r, and the reason I'm doing that is because I'm clever, and I want to use this relationship so that I can get an r squared on this side right here. I can just put x squared plus y squared in place of that. And then the r's reduce out, and that's where I get the 4x that you see on this side. So anyway, basically what you would have is this is your equation, and all of you in calculus and all of you in pre-calc that have had pre-calc, you should know that this is an equation of a circle. And we could do more with that, but I'm not going to do that. I didn't do it on the other video. Alright, so this one, well, r is equal to a 2. So I need to use the version of this r squared that you see right here. I want to solve it for r by taking the square root of both sides of this thing up here. So that means when I see this, I can have the square root of x squared plus y squared, but then I need to get rid of the radical so I can make it look like a typical equation. So I squared both sides, and I ended up with this equation right here, which is a center at the pole or a center at the origin. And I think there's one more page. And again, I'm just going to talk about what I've already written here, since I already did all this. Now, with this equation, what I did is I factored a 2 out. Why did I factor a 2 out? Is I noticed that that was x squared plus y squared, so I could put an r squared in place of that. That means then I'm supposed to solve it for r, so I divided both sides by 2 and got what you see right there. And then I need to take the square root of both sides. And what's really kind of interesting is in a later video you're going to hear about graphing these things by recognizing the equation. The thing that I've been preaching from pre-calc, college algebra, whatever, you need to start recognizing polar equations and the kinds of shapes that they have. And that's a video coming to a theater near you, or a computer near you. Alright, finally, this is my vertical line, x is equal to 0. You should know that from college algebra and from pre-calculus. And I'm going to substitute what x is equivalent to, which is r cosine theta is equal to 4. And this, to me, is an okay answer because that's what we're going to use to graph later when I show you and try to help you recognize things. But for the Calc 3 students that are listening to this, I'm going to divide both sides by cosine, and I end up with r is equal to this, which if I had the time and energy to do this, I'd say what does it simplify to be? And this is also the same vertical line. Alright, so I guess I just saved 20 minutes of your life to do 60 minutes of my life. So anyway, I'm going to hopefully not lose this one.